Graphing polynomial functions. For the polynomial f of x equals negative 2x to the fourth minus 4x cubed, answer parts A through E. Part A, use the leading coefficient test to determine the graph's end behavior. First, we're going to identify the leading term. So the leading term is negative 2x to the fourth. That's the term with the highest exponent. Now the degree of the polynomial is 4, which is an even number. And the leading coefficient of the polynomial is a negative 2. And that's a negative number. So that's less than 0. Now we're going to look at our chart below to see which outcome fits our problem. And we'll see that for n is even and the leading coefficient less than 0, that the graph falls to the left and falls to the right. So that means that our tails will look something like this. Part B, find the x-intercepts. State whether the graph crosses the x-axis or touches the x-axis and turns around at each intercept. To find the x-intercepts, we'll set our function equal to 0 and solve for x. First, we want to factor out a common factor, which is a negative 2x cubed. When I do that, I get x plus 2 equals 0. And then I'll set each term equal to 0 and solve for x. So with negative 2x cubed, I'll divide both sides by negative 2, and I have x cubed equals 0. Now notice that we have a cubed here. That means that my solution to x cubed equals 0 is going to have a multiplicity of 3. And then when I solve this, I'll take the cube root of each side, and the cube root of 0 is just 0, so that means that x equals 0, and it has a multiplicity of 3. And then with x plus 2 equals 0, I'll subtract 2 on both sides, and I get x equals negative 2, and that has a multiplicity of 1. Now I want to know if the graph crosses the x-axis or touches and turns around at that point. So if I look at x equals 0, I can see that I have a multiplicity of 3. That's an odd multiplicity, so I know that the graph will cross at x equals 0. Now if I go to my second 0, I have x equals negative 2, and that has a multiplicity of 1. This is also an odd number, so I know that at x equals negative 2, my graph will also cross. Part C, find the y-intercept. The y-intercept is found by plugging in 0 wherever we see an x in the original problem. If we simplify this, we get f of 0 equals negative 2 times 0 minus 4 times 0. This is 0 minus 0, so f of 0 equals 0, and the y-intercept is 0, 0. Determine whether the graph has y-axis symmetry, origin symmetry, or neither. Graphs have y-axis symmetry if f of x equals f of negative x. So to test this, we're going to first find f of negative x. And f of x is written up in the right corner, and we're just going to replace a negative x wherever we see an x in the original function. So we have negative 2 times negative x to the fourth power minus 4 times negative x cubed. Negative x to the fourth power is a positive x to the fourth power. That's because a negative raised to the even power is always positive. If we look at our next term, negative x raised to the third power is the same as negative x cubed. That's because a negative raised to an odd power is always negative. So we'll multiply that negative x cubed to the 4 in front, and then we're going to simplify this so we get negative 2x to the 4th. A negative times a negative is a positive, so it's plus 4x cubed. And this equals f of negative x. Now we want f of negative x to equal f of x. And if we look up top, f of negative x does not equal f of x. And that's because the middle signs are different. So we can say that the graph does not have y-axis symmetry. Now we'll test origin symmetry. To see if the graph has origin symmetry, we're just going to compare the f of negative x and see if it equals negative f of x. So we already found f of negative x. Now we're going to find negative f of x. That just means that we're going to change each of the signs in the original function. So we're taking the negative of negative 2x to the 4th minus 4x cubed, and again we're just going to change each sign. So we get a positive 2x to the 4th plus 4x cubed. And if we compare the f of negative x to negative f of x, we can see that those things are not equal. So our graph doesn't have origin symmetry either. Since it doesn't have y-axis or origin symmetry, then our answer is neither. If necessary, find a few additional points and graph the function. Use the maximum number of turning points to check whether it is drawn correctly. Choose the correct graph below. We're going to use the information we found in the previous parts to graph this function. So we have x-intercepts at 0 and negative 2. If we look at graph A, we have 0 and negative 2 here. In graph B, we also have 0 and negative 2. In C and D, we do not have the correct x-intercepts, so I know I can cancel those out. The y-intercepts of 0, 0 are also on graphs A and B. Now, in part A, we found that the graph should fall to the left and fall to the right. That means that our tails will look something like this. The only graph that fits that criteria is choice A. So choice A is our answer.